Welcome to Algo Guru, and in this video we are going to take a look at some of the problems related to arrays. Arrays is one of the very basic data structure. With the specialty of this is that it is contiguous memory, and as far as like getting an element from an index and also setting an element into an index, it will just take like a big of one time complexity. So let's dive in and try to solve some basic array related problems which could potentially come up in coding interviews. All right, the first problem that we are going to look at is how to separate odd and even numbers in a given array. And I have an input array which is very straightforward. Like you look at 1, 2, 3, 4, 5, 6, 7, 8, 9, and 0. And the output of this function is going to be like 1, 3, 9, 5, 7. So those are all the odd numbers on the left side. And then 6, 4, 8, 2, 0, which will be all even numbers, which will be on the right side. And as you can see, the input is a mix and match kind of thing where it is in chronological order 1, 2, 3, 4, 5, 6. So how can we do that? So the first step is to get the nums dot size. So this is going to give us the size of the array. So that's the first thing that we are going to do. So as soon as we get that, the next step is going to determine like what we are going to do. So in this case, I'm going to do like a while loop. And in this while loop, I need something like an int left. And then I also need an int right, which will be n. And now I will have a while loop, which will start from left. And it has to be like less than n, which will be the size of the array. And then what will I be doing? Like I will check starting from the 0th index. I will check whether this is an odd or even. So that's basically the if condition is going to do. So in this particular case, okay, I'm going to check whether this is an even number. If it is an even number, I don't really care. I'm just going to like keep going. I'm just going to keep incrementing the left pointer. So what if it is an odd number? At that particular point of time, I need to swap the numbers. So how am I going to do that? So I'm going to do something like this, left, and then I'm going to do like minus minus right. So so that's basically what it is. And let me write a test case over here. So I already got like a test function over here. So let me copy paste this all thing over here. And then I will have this, I will call this function, which is odd even, and then I will pass nums into it. And after that, I need to print. Okay, so it's not nums, it's input. Okay, I will keep that as nums. And then I will have this over here, and then I will basically print all the elements over once it has been processed. So that's what I will be doing. Let me take a look at it. Okay, so what do I got over here? I got 1, 3, 9, 5, 7, then 6, 4, 8, 2, 0. So all these are all the even numbers on the right side, and then all the odd numbers on the left side. So that's basically it. It's a pretty straightforward problem, and it basically uses a while loop. That's basically it. Um, the important thing is like making sure that you do the check over here, and then based upon that you will just do the swap. All right, let's jump into the next problem. The next is like partitioning an array based upon a pivot. So this is an extension of what actually we tried earlier. So this is like going like one step ahead. So in this particular problem, you can see that you have given an input array. So I'm using the same input array. And then there is a pivot. Pivot is 4. So what does that mean? I will pass an index, and I'm going to pass in this particular case. All right, so I have to say like p is equal to 3. So that's what I'm going to do. So 0, I will start it here, 0, 1, 2, 3. So pivot I will take as like 4. So let's jump into the code, and let me do it. So nums.size, and then pivot. You can see like how I'm going to calculate pivot. That's it. Just use that argument p and then find the pivot, and then again you will have like two variables. I will like set I is equal to 0, which will basically be the left side, and then j is also is equal to 0, and then I will have like a right, which is going to be in. Again, what I'm going to do is that I'm going to start a while loop. So in this case, I will be here. I going to be less than right. So I will have to do like a check over here to see like, okay, nums of I, if it is less than pivot, what will I do? I will have to swap. So I will have to swap I plus plus. As soon as like I swap, I also want to do an increment of that. So that's the reason I'm having like this particular condition. So nums of I equal to pivot. What will I do? I think I will just do like an I plus plus, because I don't have to really do no swapping. Nothing is needed at that point. So what if nums of I is greater than pivot? So okay, so that's a tricky case. So what I'm going to do, I will again swap it with nums of minus minus right. The reason why I'm doing minus minus is because I have given like right is equal to n. So if I use right directly, it's going to crash because it's out of bounds of the array. So that's pretty much it. I got all these things covered as long as I is equal to right. So I keeps like incrementing. I keeps incrementing at 2 places, and then right keeps decrementing at this particular place. So this is the case where wherever I is, if that value is like greater than pivot. All right, so let me come over here. The test case is a small change. I will come here and I will make it like 3, index 3, which will be going into like 4. All right, so look at this. So this is the pivot, and everything less than that is over here on the left side, and everything greater is on the right side. That's pretty much it. So I can make the pivot to be 5. Let's see what index 5. So that is here. It's index 4 and the value is 5. Just a clarification. All right, so if I do that, see the pivot is here, everything less is on the left side and everything greater is on the right side. And again, understand that this is not in sorted order. So basically quicksort works on multiple iterations, multiple recursive calls on the same logic, but it takes into a next level, and then finally everything, the entire array will get sorted, even though in this particular case we already have like array sorted. to the most part. Only one element is actually outside the scope. So that's pretty much it. Like as you can see over here, I'm passing this array and I'm going to get something like this. But again, like because I'm only calling it one time, it is definitely not in this order. As you can see, the order will be changing. So you have to do like multiple calls and use the quicksort algorithm. And the purpose of this coding problem is not quicksort. This is like using somewhat like a similar logic, and you are like partitioning the array based upon a pivot. Well, the next question that I'm going to have a shot at today is add 1 to an array element. And let's think of array as an integer, but every digit is like split into different. So for this example, 1, 2, 9, and I have to add 1 to that. Just think about it as an integer, 129. You add 1 and it becomes 130. So that is the resultant array. How can we do that? We can do it in so many different ways. Like just get all the elements, make it like an integer, and then do it. But what if the size of this array is like a 100 or something? That means it has gone beyond not just integer, long and everything, right? So that's where this particular function comes in handy. Let's jump in, and the first thing we do is that we get the size of the array, and remember we are using a vector. Vector is a dynamic array which is part of the standard template library. All right, so this is going to be tricky, so we need a carry, and the reason why I'm initializing that to 1 is because it's add 1. Add 1 is the reason why carry is 1. And now just go through this whole thing, like starting from n minus 1, I greater than equal to 0, minus I. That's so that's our loop, and the first thing, let's get the sum at that particular point, at that particular loop. So we start from the end of the array and add carry to that. In this particular case, because we are adding 1, we already like by default at line number this one, at this particular line, we have that already set to 1. Once we get that, this could be a larger number. For example, if it is 9, you add 1, it becomes 10. So sum is 10. We cannot add that to the resultant array. So let me add a resultant array 2 over here. All right. So we need to like chop it off. How will we chop it off? So we will have like a ternary operator like this. So if sum is greater than 9, so what will we have? We will just use 0. Okay. So the last nums of I was 9 and carry was 1. So sum is 10. And in the total, it is, when we look at sum is 10, 10 greater than 9. So we will just take the 0 part of that. If it is less than or equal to 9, then we will take the whole thing. And the same condition, we need to also we find the total, and then we also find the carry. So here, instead of we will have like 1 and 0. Okay, if sum is greater, then we will have carry as 1. And then we will just add that into the result. So now the trick is like, okay, so once we come out of this, what if there is still a carry element over there? Then we need to add that also, right? So we know that at that point the carry is 1. Carry cannot be like, it's either 0 or 1. It cannot be like 2, 3, 4, anything like that. It's impossible. And at this point, we will need like a reverse, because we are just adding at the back. So we need to reverse this. Otherwise, it's not going to work. All right, so we are going to reverse this array. And then what we will do, for the sake of this solution, what I'm going to do is that I'm going to just like set nums. I'm passing nums as a reference here, so I'm just going to set nums is equal to result. Let's see, let's run a test case and see like whether this will actually work. Okay, so I can like just get rid of all these things. All right, so we are passing 1, 2, 3, and we get 1, 2, 4, which is exactly what we want, right? 2, 2, 9. What should be the result? 230. Let's see whether we get 230. There you go. We get 230. So this is working fine. So let's do like something more trickier, like what if it is like 9999? So this should come back as 1000. Will it? Let's find it out. There you go. It comes back as 1000. There you go. So that's how it is working. So that's for this video. And this is basically an introduction. And that's the reason why we just went through like very simple basic coding problems. And in the subsequent videos, I'm going to go some level up and come up with some more difficult ones. See you then. Bye.